Hey there and welcome to our OOP series. We'll be learning this series in 3 steps, starting from beginner, then intermediate, then advanced. We'll be using Java in order to learn this, but don't worry about the language as we'll be focusing on the core concept. So just let's get started. Let's leave the technical jargons aside, just let's focus on what exactly is object-oriented programming. So example, I have a factory, a warehouse where we manufacture ceramics. We have bowls, we have cups, we have plates and all. So if I want to manufacture 100 cups, so will I put the labor in making the cup completely from scratch from the mud, then making its handles and all? No, I will just simply create a mold and then put the ceramic inside it and our cups will be ready. So here in object-oriented programming, we can call the mold as a class and the cup as an object. So class acts as a blueprint for the object, and in order to make the object, we can just simply refer it to the class and receive our ready-made objects. So now that we know why we need object-oriented programming, let's take an example of a short code and understand the basics. So right here, first of all, we have a cup class. So we need to make a cup, and for that we designed this class. Now this class acts as a blueprint, acts as a mold for making a cup, and this particular blueprint has all the attributes that would be needed to make a cup. That would include the brand, the weight and the create function. Now to make our first cup, what we would do in our syntax is we would state here cup, which is the class, and the first cup, and this would be the syntax as follows. And now to give the properties to our cup, we would just use the dot attribute. We would access first cup dot brand equals to IKEA, first cup dot weight equals to the weight that is given, and hence doing so, our first cup will be assigned the two values, its brand and weight respectively, and so on. We can just write multiple cups and assign them multiple values. Now when we are trying to print the values of these cups, we can just invoke the create method that is already listed inside our blueprint class, that is the cup. Now let's try running this program. So as we can see, we have invoked the two create methods here, which is for the first cup and for the second cup. So both of them print the same thing, the cup is created. But how would we differentiate the two cups that we have? So here what I would additionally do is a cup is created of brand, and the brand would be listed here. Okay, and the same our cup is created of weight, as it will be listed here. And after saving this code, now when I try to run it, what should I get? I should get both of individual brand values and individual weight values. So let's see. So here as we can see, first we have invoked a cup1 method, which is create. So we have got all the attributes of cup1, that is IKEA and 100 grams. And after invoking the second method, we get the second cup's attributes, that are XYZ and 120. So this is like sort of a gist of what is object-oriented programming, and now we will be moving to our next topic. Now that you have a bank account and you can't directly edit your account balance, right? You can either deposit your balance, and which would result it in a higher amount in the total balance, and you could additionally get the balance, but you can't directly change the balance as we could change the brand's name in our cup example, right? So this is called as encapsulation, and let's see an example of this. So here we have our static class called bank account. So this is again a template, a blueprint from which a person's account can be found. Now our balance should not be changed under any circumstance directly. So what we would do here is we would just name this particular variable as private. Now what benefit do we get from assigning this variable as private is, when we come to our main function and suppose I want to edit the balance, suppose I want to write account dot balance equal to 1 lakh. So if we write this, then we will get an error from Java. So this is the purpose of using the private keyword, and hence what encapsulation does is it just shows us the usable data that we need to see, not the data that is vulnerable for a particular class. It just bundles the necessary methods and necessary keywords that the user needs to see. So like my current balance is 1000, and now if I want to deposit 500 rupees in my account, and then I would use a method called getBalance to get my current balance. Let's save this, and after compiling, so now as you can see here, whenever we deposit 500 into our account, the deposit functions gets called, and upon getting this function called, our balance would be increased by the amount that we are adding, the amount that we are depositing to our current balance. And so as to get our balance, we would use a getter. So what a getter does is it fetches the private keyword that are inside a class, which cannot be accessed directly. So after writing get balance, we can easily see our total balance that we have. Now moving to the next topic. So whenever we take a coffee from a coffee machine and we just press our desired button, the coffee that we need, it might be an espresso or a latte, right? Do we come to know how much water is remaining inside it, what is the coffee powder, how much we need to roast it? Why don't we know all about this? Because these details are just unnecessary. So this is the concept of abstraction. What it does is it hides all the unnecessary data from the user and just gives the user what he just needs. Okay, so now let's see a small code snippet to understand abstraction much further. So here we have our coffee machine class. Inside our coffee machine, we would have these variables which are water temperature and the amount of coffee powder that is left. Now I'll create an object for the coffee machine, and I would command the object to make our coffee. So while making the coffee, what would happen internally is it will boil the water, right? Then it will brew our coffee. It would roast the beans and then grind them and brew our coffee, right? So while boiling the water temperature will rise, and while brewing coffee, our coffee powder would decrement in proportion. So what the user will do with all these unnecessary data, right? We just need to make the user that our coffee is ready. We just need the user to know that our coffee is ready directly, right? So I'll just command our object to make our coffee, and now let's try running this program. As we can see here, rather than knowing all the unnecessary data, that is the water temperature and the coffee powder that is left, we just get to know your coffee is ready right away. So this is the concept of abstraction. Now moving to the next topic. We'll now take in account of access specifiers, getters and setters in object-oriented programming. So this is a demo class of a student. Now we'll consider 3 attributes of student. That would be age, one is marks, and one is name of the student. So I want the name to be public, any different class or any variable or any object would be able to access its name, right? But the marks I want it to be confidential, like a banking password maybe, or something that is not meant for any other object to access. So I would want the marks to be of that behavior. So what I can simply do is I would give a keyword public to the name of the student. But whereas I will give private to the marks of the student, because I don't want marks to be accessed by any other means. Okay, so here is a small snippet. Here I gave name a public keyword, I gave marks a private keyword. So in order to edit the marks, in order to change the marks, in order to see the marks, what we would need to do is we would need to specify getters and setters. So what getters and setters do is safely access the value of a private variable. How that happens is whenever we call get marks, we can return this marks safely in a proper constructive manner. And if you need to set marks, instead of saying a student name dot set student name dot marks equal to 100, we have this procedure over here where marks are needed to be greater than 0 or less than 100. If this condition is specified, then we can change the marks that are assigned to the student. Also, we have a third type of a new access specifier that is protected. Now we would learn more about this in the next video, which would cover the concept of inheritance. So what inheritance does is, this is our class, and if we derive a class from this class called a subclass, then whatever the protected variable is, its value could be utilized inside the subclass only. So it is not private, but only subclass can inherit it privately. That is called as a protected type of access specifier. So that was our first part of the object-oriented programming mini-series. We covered all the concepts including the classes, objects, encapsulation, abstraction, access control, like access specifiers, getters and setters. So these are basically all the Avengers constituting the object-oriented programming. Drop a comment if you found this helpful. Subscribe to stay tuned for the next video. We'll be covering about polymorphism, inheritance in next ones, and you would get to know much more about how classes and object actually come into play. Thank you for watching.